For over a century, human transportation has been powered by a system of controlled violence. You can feel it in the deep vibration of the steering wheel, the roar of the exhaust, and the immense heat radiating from the hood. That sensory feedback is the result of a very literal, very physical chain reaction. We pump liquid fuel into a tight metal chamber, ignite it, and use the rapid expansion of those burning gases to forcefully shove heavy steel pistons up and down. But step on the accelerator of a modern electric vehicle, and the experience is entirely different. You get immediate, blistering speed, completely decoupled from the roar and the rattling. Underneath the hood, there are no miniature detonations happening thousands of times a minute. There is no tank of combustible liquid. There isn't even a traditional gearbox clicking through ratios. It takes an immense amount of physical energy to hurl a 4,000-pound block of metal down a highway. If absolutely nothing is catching fire or blowing up inside the machine, where is all that force coming from? The answer reveals how transportation has moved away from chemical fires. We are now propelling ourselves forward using the precise, invisible manipulation of electromagnetism. In this transparent chassis schematic, we see the core components. A flat battery spans the floorboard, feeding an inverter, connecting to a motor. That flat battery pack locks massive energy chemically. Pressing the accelerator instantly converts that stored energy into a continuous stream of direct current electricity. This raw, flat line of power surges forward out of the battery pack, but it can't drive the wheels on its own. It must pass through an intermediary. That intermediary is the inverter, the operational brain and translator of the entire propulsion system. The inverter performs a structural transformation. It takes flat direct current and structures it into alternating current, a rapidly oscillating wave. This is an absolute requirement. Steady streams can't push heavy cars. Electricity needs to pulse to build shifting magnetic fields. Without the inverter carving that raw, flat power into a rhythmic wave, the battery's massive energy reserves would just sit there, trapped and entirely useless to the motor. Now riding that oscillating wave, the electricity rushes out of the inverter and enters the outer ring of the electric motor, a stationary cylinder packed with tight coils of copper wire, called the stator. As AC electricity travels through the stator, it generates a circular, rotating magnetic field. Suspended inside is the rotor, sitting completely free. The stator's spinning magnetic field grabs the rotor, forcing the inner cylinder to spin rapidly to chase that rotating field. Notice the total absence of friction, no steel parts slamming into walls. No gears grinding against one another. The inner cylinder is dragged purely by invisible forces of magnetic attraction and repulsion. That rapidly spinning inner cylinder connects directly to a drive shaft. As the rotor turns, that pure rotational energy is sent straight into the wheels. Thousands of pounds of steel, glass, and passengers are physically hurled down the road by nothing more than copper wire and the tight, invisible grip of magnetic fields. Zooming out from the microphysics of the motor allows for a direct comparison between these two systems on a macro level. This bar chart compares the sheer efficiency of both systems. In a traditional internal combustion engine, up to 80% of the energy generated by burning fuel is entirely wasted. It bleeds out into the atmosphere as heat, friction, and noise. Only 20% actually moves the car. Watch what happens when we plot the electric vehicle's performance alongside it. By using electromagnetism, the electric motor successfully converts up to 90% of its electrical energy directly into physical, forward motion. That massive gap in efficiency exists because of what we removed. Stripping out hundreds of heavy, interlocking mechanical parts and chaotic explosions eliminates the exact things that cause friction and energy waste in the first place. While this shift meets an environmental necessity, it also marks a move toward mechanical precision. We replaced a sprawling machine that constantly fights itself with a streamlined system that simply flows. The roar and the rumble of the highway are slowly fading out. We are now permanently trading the chaotic, lossy age of combustion for the quiet, frictionless efficiency of electromagnetism.